Alright, so last time we just covered why two negative when multiplied are equal to positive values. So we covered that, and I'm going to continue reading the Spivak calculus textbook from where we finished, right? Okay, so the various consequence, let me zoom it up a little bit. The various consequence, come on, let me pick a color, a black color, so it's more visible. The various consequences of P9 examined so far, although interesting and important, do not really indicate the significance of P9. After all, we could have listed each of these properties separately. Actually, P9 is the justification for almost all algebraic manipulations. For example, although we have shown how to solve the equation x minus 1 times x minus 2 is equal to 0, we can hardly expect to be presented with an equation in this form. We are more likely to be confronted with the equation x to the power of 2 minus 3x plus 2 equal to 0. The factorization is really a triple use of P9. And there we go, the steps to find how the equation has been derived, right? So this is one of the techniques that many people will go through without looking at it first time, because they remember how the quadratic equation looks like. Remember, it's a minus b plus minus 4 4ac. No, I think I forgot. What was the quadratic equation? I forgot. Long time. But we can find out, right? Let's see how it's done. From the factorization to this equation, right? How we go from one to the other. Let's see. So we have this is really not Spivak, but I just want to remind myself how the equation is, but it's done without actually looking at the quadratic equation form, right? So x to the power of 2 minus 3x plus 2 is equal to x minus 1 times x minus 2. I'm not going to write down the factorized form yet, because I don't want to spoil myself into thinking I know the solution. So how do we factor it out? Like we using the P9 property 9 of that of the numbers, and which is a distributive property, right? Let's write that down. A times b plus c is equal to a times b is equal to a times c. Write that down on the side so I can just use it at ease. Yellow. So x okay. So first of all, negative 3x is what? What is negative 3x? Is there something we can do about it? Yes. Absolutely. Um, dun, 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 dun. Yeah, so here, x, this equation above is equal to x squared minus x minus 2x plus 2. Using the distributive property, we can factor this out. This term, these two terms, which is x times x minus 1, and these two terms into minus 2 times x plus 1. Oh, actually, x minus 1. Because the second term has to be, second operation has to be minus, because when multiplied it becomes positive. And then these two terms share the common factor, so we can use again distributive property. X minus 2, x minus 1. I kind of wanted to get start from the quadratic equation, but to derive the quadratic equation from here, but the distributive property is more intuitive approach for this one. Well, it's just talk, so let me get this straight. So yeah, we've derived the factor of x squared minus 3x plus 2 using distributive properties of numbers. But I kind of also want to get the generalized equation where ax squared minus 3 plus bx plus c equals 0. The solution to this is c minus b plus minus b squared minus 4ac over 2a or something. I don't know if this is right, but I can definitely derive solution from this equation. So first of all, suppose a is not 0. If it is, the solution to this is solving the linear equation bx plus c. So we're not going to cover the case where a is 0. So we can divide this a by whole equation by a, then makes this equation to a b over a x plus c over a. And then x squared plus b over a, x is equal to negative c over a. And then here we have x times x plus b over a x, b over a is equal to negative c over a. Never mind. Let's think of it this way. When we do x plus b times x plus b is equal to x squared plus 2 bx plus b squared, right? Okay, let's use this fact and then see if we can derive quadratic equation of this form, hopefully. Okay, so x squared plus b over a x plus yeah, let's do this. What is x plus b over 2a x squared? What is this? X squared b over a times x plus x squared. Oh, no. Let's skip the x part. And then I'll remove the x part. Then it becomes 4a b squared over 4a squared. Oh, okay, so we can make this into x squared plus b over a x plus b squared 4a squared minus ba 4a squared, which makes this 0, so we didn't change anything to the equation. So basically this is equal to negative c over a. So then what we can do is we can use these three terms to factor out x b over 2a squared minus b squared over 4a squared is equal to minus c over a, right? So then x squared, x plus 2a is equal to, when moving it over here, so c a plus b squared over 4a squared square root, because there was a square here, then x is equal to minus b 2a plus b squared 4a squared minus c over a. So then we clean this up. Which is two ab is equal to b squared minus 4ac to make this denominator 4a squared. Okay. Yeah, I can go a little more steps to go from here to here, but I leave it to you, this simplification, right? If you don't know how, I'll go over in a couple of next videos, but see if you can see if you can do it. Then this denominator term is square rooted, which makes it minus b plus minus 4ac over 2a. Okay, so I added a plus minus sign because it depends really on when something is square rooted, both positive and negative value form that squared value, meaning say if b squared minus 4ac is equal to 4, right? When we square root this, square root of this big thing, let's call this a is, it can be negative 2 or 2, both works. So I'm putting positive and negative value to consider both cases in the quadratic equation. So yeah, this is the generalized solution when we have a coefficient on the quadratic equation, which is not really necessary to cover in this textbook reading, but regardless, it was a fun journey. Let's continue to read the Spivak textbooks in the next couple of videos, and we'll go from there. Thank you for watching. Oops.